This factory in Kentucky produces 20 million Pop-Tarts every single day, each one filled, crimped, and frosted in under 3 minutes from raw dough to finished pastry. The filling must be deposited at exactly 62 degrees, 1 degree warmer and it bleeds through the dough, 1 degree cooler and it fails to spread evenly. That precision explains how a product invented in 1964 became America's best-selling toaster pastry for 6 consecutive decades. Today, we are following every step inside one of the most advanced pastry operations in North America to reveal the engineering behind this breakfast icon. How does a factory seal fruit filling between 2 layers of dough 3 billion times per year without a single leak reaching store shelves? The answer involves dough stretched to within hundredths of a millimeter, filling temperatures controlled to single degrees, and crimping dies engineered to microscopic tolerances. This single facility supplies Pop-Tarts to retailers across 43 states and 14 countries, shipping over 7 billion pastries annually. But the journey from commodity ingredients to frosted breakfast staple begins with raw materials that must meet specifications most bakeries would never attempt. Every Pop-Tart begins with wheat flour, milled to protein content. Specifications so precise that each delivery gets laboratory tested before acceptance. The flour arrives from dedicated mills in the Midwest, ground from winter wheat varieties selected specifically for the tender, flaky texture Pop-Tarts require. Protein content must fall between 9 and 11%. Higher protein creates tough pastry. Lower protein causes the dough to tear during sheeting. Vegetable shortening arrives in temperature-controlled tankers, kept at exactly 21 degrees to maintain the consistency essential for flaky layers. Protein sugar comes from 2 sources, granulated for the dough and powdered for the frosting, each with different crystal sizes optimized for their specific role. The fruit fillings arrive pre-made from specialized suppliers, cooked to exact moisture levels that prevent both sogginess and excessive dryness. Strawberry filling alone requires 14 separate ingredients, each one contributing to the flavor, color, and texture that consumers expect. The fruit content comes from real strawberries, processed and concentrated to intensify flavor while controlling the moisture that could compromise pastry integrity. Every incoming ingredient receives a lot number that tracks it from delivery dock through production and all the way to retail distribution. Samples from each delivery get retained in climate-controlled storage for 18 months, available if any quality concerns arise after products ship. The frosting ingredients follow their own strict protocols. Corn syrup, sugar, and palm oil must arrive at specific temperatures to blend properly. Food colorings undergo spectrophotometer testing to ensure the exact shade of pink or brown that matches the flavor profile customers recognize instantly. Sprinkles arrive pre-made in exact color combinations, each batch verified to contain the proper ratio of colors for each Pop-Tart variety. Only after every ingredient passes inspection does the production computer authorize release into the mixing and blending systems. The approved ingredients now flow through dedicated pipes and conveyors to the mixing room where the transformation begins. Temperature-controlled holding tanks keep each component at optimal conditions until the mixing computer calls for them. What happens next transforms these commodity ingredients into the dough that will become millions of identical pastries. But the dough is only half the equation. In parallel rooms, the fillings and frostings are being prepared with equal precision. The dough mixing process follows a sequence that took years to perfect. Dry ingredients combine first, creating a uniform base before fats enter. The mixer runs at low speed for exactly 2 minutes, allowing the dry ingredients to blend without creating the gluten development that would toughen the pastry. Chilled shortening enters next. Cut into the flour mixture by specially designed paddles that create the small fat pockets essential for flakiness. Water temperature matters critically. It enters at exactly 4 degrees to keep the shortening cold and prevent premature gluten formation. Total mixing time is under 5 minutes. Any longer and the dough becomes overworked, losing the tenderness that defines a good Pop-Tart. A technician pulls a sample from every batch, pressing it between fingers to verify the texture shows proper fat distribution. Approved dough moves to refrigerated resting chambers where it relaxes for 30 minutes, allowing the gluten to relax before the violent sheeting process. Meanwhile, in the filling room, fruit preparations undergo final heating and blending before being pumped to the production line. The strawberry filling heats to exactly 74 degrees, hot enough to ensure food safety but cool enough to prevent fruit flavor degradation. Continuous stirring prevents scorching on the kettle walls, where contact with hot metal could create bitter notes that ruin entire batches. The filling's viscosity gets tested every 15 minutes. Too thick and it won't spread inside the pastry. Too thin and it leaks during crimping. Brown sugar cinnamon filling follows different parameters entirely, requiring lower moisture content to achieve its characteristic crystalline texture. The 40E filling pumping system maintains constant pressure, ensuring every depositor receives identical filling flow regardless of demand fluctuations. In the frosting room, a completely different chemistry unfolds. Sugar, corn syrup, and fats combine into the glossy coating that makes Pop-Tarts instantly recognizable. The frosting heats to 100 degrees, then cools to exactly 42 degrees before application. This temperature creates the perfect adhesion to warm pastry. Food coloring additions happen at precise moments during cooling. Added too hot and the color fades. Added too cool and it won't incorporate evenly. Each frosting variety has its own temperature profile. Chocolate requires different handling than strawberry, which differs from blueberry. The finished frostings circulate through heated pipes that maintain exactly 42 degrees throughout the coating system. Back in the dough room, the rested mixture emerges cold and firm, ready to be transformed into endless sheets of pastry. The next 12 minutes will transform these separate components into the assembled pastries that have defined American breakfasts for generations. The sheeting line stretches 60 meters through the factory, progressively rolling the dough from a thick mass to a thin, continuous sheet. The first rollers compress the dough from 15 centimeters to 3 centimeters in a single pass, applying pressure equivalent to 4 tons. Sensors measure dough thickness 60 times per second, automatically adjusting roller gaps to maintain consistency within 0.05 of a millimeter. Each subsequent roller pair reduces thickness further. 3 centimeters becomes 1, then 0.5 centimeter, approaching the final target of 2.5 millimeters. The dough sheet now travels at 8 meters per minute, accelerating as it thins to maintain consistent mass flow through the entire system. A dusting system applies a microscopic layer of flour to prevent sticking, using just 12 grams per square meter of dough surface. The final thickness of 2.5 millimeters creates the perfect balance. Thin enough to crisp during baking, thick enough to contain the filling without tearing. The continuous sheet now divides into 2 layers. The bottom sheet will carry the filling. The top sheet will seal it inside forever. Everything that happens next occurs in synchronized precision. The filling, the sealing, and the crimping must align perfectly or millions of pastries fail. The bottom dough sheet arrives at the depositor station, where 48 nozzles wait to place filling in perfect grid formation. Each nozzle fires for exactly 0.3 seconds, depositing precisely 19 grams of filling in a rectangular pattern matching the pastry dimensions. The filling temperature at deposition is exactly 62 degrees. This precise temperature ensures the filling spreads to reach the edges without bleeding through the dough. 48 Pop-Tarts form simultaneously across the width of the line. In 1 second, enough pastries for an entire family's week of breakfast take shape. The top dough sheet now descends from above, lowered by precision guides that align it perfectly over the filling-covered bottom layer. Contact happens at exactly the right moisture level. The 2 dough surfaces bond naturally where they touch, creating a preliminary seal around each filling deposit. But this natural bond would never survive baking. The crimping dies are what create the seal that keeps filling inside through toasting temperatures. The crimping dies strike with 400 kilograms of force, compressing the dough edges and cutting the distinctive scalloped pattern that defines every Pop-Tart. That scalloped edge is not decorative. Each crimp point creates a mechanical interlock that prevents the seal from separating when steam pressure builds during baking. The dies cycle 12 times per second. Each stroke produces 48 sealed pastries, nearly 600 Pop-Tarts created every second the line runs. Waste dough from between the pastries gets immediately recycled, sucked through vacuum tubes back to the sheeting system for incorporation into fresh batches. The sealed but unbaked Pop-Tarts now flow toward the oven, still soft and pale, carrying their filling cargo toward the transformation heat brings. The tunnel oven stretches 45 meters, divided into 6 temperature zones that transform soft dough into crisp golden pastry. Zone 1 hits the pastries with blast heat at 210 degrees, rapidly setting the outer surface before internal steam can distort the shape. The sudden heat causes moisture in the dough to flash to steam, creating the tiny air pockets between layers that give Pop-Tarts their distinctive, flaky bite. 2 and 3 maintain 190 degrees, allowing heat to penetrate to the center without burning the exterior. Inside each pastry, the fruit filling reaches 74 degrees, hot enough to pasteurize any remaining bacteria while the surrounding dough protects it from direct heat. Zone 4 reduces to 170 degrees, beginning the controlled cool-down that prevents thermal shock from cracking the crisp pastry shell. The final zones apply gentle finishing heat while powerful exhaust fans remove moisture-laden air, crisping the exterior to exact specifications. Total baking time is exactly 4 minutes 30 seconds. Each pastry has traveled through the oven at precisely 10 meters per minute. The pastries exit at 140 degrees, far too hot for frosting. The cooling tunnel ahead will drop them to the exact temperature coating requires. Chilled air at 4 degrees flows opposite to the pastry direction, creating a gradual temperature gradient that prevents condensation from forming on surfaces. Workers pull samples at the tunnel exit, breaking pastries to verify the filling reached safe temperatures and the seal remained intact through baking. The cooled pastries now register exactly 38 degrees, the precise temperature at which frosting will adhere without melting into the surface. Everything that happened so far has created an unfrosted pastry. What comes next transforms it into the iconic Pop-Tart that consumers recognize instantly. The frosting waterfall is the heart of this transformation. A continuous curtain of colored icing cascades from above, coating every pastry that passes beneath. The frosting temperature of 42 degrees creates perfect viscosity, thin enough to flow evenly, thick enough to remain on top without dripping off edges. Each pastry receives exactly 14 grams of frosting, controlled by the combination of curtain width, flow rate, and conveyor speed. Excess frosting falls through gaps in the conveyor belt, collected in a heated trough that returns it to the coating system for reuse. Immediately after coating, the pastries pass under the sprinkle applicator, where thousands of colored candy pieces rain down onto the wet frosting surface. The sprinkles must land within 3 seconds of frosting application. Any later, and the surface begins to set, preventing proper adhesion. Different Pop-Tart varieties receive different decorations. Some get sprinkles, others get drizzled icing patterns, and some remain plain frosted. The drizzle applicator uses computer-controlled nozzles that trace precise patterns across the frosting, creating the decorative swirls consumers expect on certain flavors. The frosting now needs exactly 90 seconds to fully set before the pastries can be handled without damaging the decorative finish. Gentle air circulation accelerates setting without creating surface defects. Too much airflow would ripple the frosting before it stabilizes. Workers at the line end inspect the frosting coverage, checking that edges are coated and sprinkle distribution appears random but complete. The transformation is complete. Raw dough, fruit filling, and sugar coating have become the breakfast pastry that sells over 3 billion units annually. But the journey to breakfast tables requires quality verification and packaging that will protect these pastries through months of shelf life. This factory runs 16 different flavors simultaneously on parallel lines, each requiring different fillings, frostings, and decorations. Strawberry accounts for 32% of production. Brown sugar cinnamon follows at 18%. The remaining half splits among 14 other varieties. Seasonal flavors like pumpkin pie require rapid line changeovers, with crews switching fillings and frostings in under 4 hours. Before packaging begins, automated vision systems photograph every Pop-Tart from above, checking frosting coverage, sprinkle distribution, and edge integrity. The cameras detect defects as small as 2 millimeters, including bare spots in frosting, missing sprinkles, and damaged corners. Rejected pastries divert to collection bins at rate of about 1%. Even this small rejection rate means thousands of imperfect Pop-Tarts daily. Verification follows visual inspection, with every pastry crossing a high-speed scale that detects variations of just half a gram. Underweight pastries indicate filling deposition problems. Overweight suggests excessive frosting. Both trigger immediate investigation. Metal detection scans every pastry for equipment fragments that could have broken off during the violent crimping process. X-ray systems provide additional safety, detecting non-metallic foreign objects like metal detectors would miss. Laboratory testing pulls samples every 20 minutes for comprehensive analysis, including moisture content, fill weight, and frosting thickness. The fill weight test requires cutting pastries open and weighing the filling separately. Target is 19 grams with tolerance of just 1 gram. Texture testing uses a penetrometer that measures the force required to break through the pastry shell. Specifications ensure consistent crispness. Tasters evaluate every flavor batch, comparing samples against reference standards kept frozen to preserve exact flavor profiles. 8 shelf life testing accelerates aging by storing samples at elevated temperatures, simulating months of retail shelf time in weeks. Consumer complaints get traced back through lot numbers to specific production runs, with data helping identify patterns before problems become widespread. This quality obsession maintains a complaint rate of less than 2 per million packages, protecting a brand that consumers have trusted for 60 years. Packaging begins with the foil pouches that keep Pop-Tarts fresh for months. Each pouch gets formed from a continuous roll of metallized film. 2 Pop-Tarts slide into each pouch, oriented back-to-back to protect the frosted surfaces from contact damage. The pouch seals with heat and pressure, creating an airtight barrier that maintains freshness and prevents the pastries from absorbing ambient moisture. Nitrogen flush displaces oxygen inside the pouch just before sealing, extending shelf life by preventing oxidation of the fats in frosting and filling. Each sealed pouch passes through a leak detector that squeezes it gently. Any pressure drop indicates a seal failure requiring rejection. The sealed pouches accumulate into groups of 4, 8, or 12, depending on the retail package size being produced. Printed cartons arrive flat, then erect and fold around the pouch groups in a continuous motion that assembles 50 boxes per minute. Codes and lot numbers print on every box, completing the traceability chain that began when ingredients first arrived at the factory. Vision systems verify every printed code is legible and positioned correctly before boxes continue toward case packing. Boxes accumulate into shipping cases, with automated counters ensuring each case contains exactly the number of retail units specified. Case sealers apply tape and labels that include destination codes directing each case to its assigned distribution center. Palletizing robots stack cases in patterns optimized for shipping stability, calculating weight distribution to prevent crushing lower layers. Stretch wrap secures each pallet, with tension controlled to hold cases firmly without crushing the boxes or damaging the pastries inside. Finished pallets move to warehouse staging, where they await shipment to distribution centers across North America and beyond. This single factory ships enough Pop-Tarts daily to fill over 200 semi-trailers, each carrying roughly 40,000 boxes. Domestic shipments reach retail shelves within 72 hours of packaging. International orders travel by container ship to ports worldwide. Real-time tracking monitors every shipment, verifying temperature conditions and handling throughout the journey from factory to store. The factory ships to grocery chains, mass merchandisers, convenience stores, and dollar stores, each with different packaging and delivery requirements. Walmart alone receives shipments that could fill 20 trailers weekly, representing the single largest customer for this iconic breakfast product. Back at the factory, the process continues around the clock. 3 shifts maintain continuous production every day of the year, except major holidays. The night shift produces identical quality because the automated systems maintain exact parameters regardless of who monitors them. 20 million Pop-Tarts leave this facility every day. By the time you finish watching this, another 50,000 have been made. What began as flour and fruit has become the pastry that defined convenience breakfast for generations of American families. The 62-degree filling, the 400-kilogram crimp, the 42-degree frosting. Each parameter perfected over 6 decades of continuous improvement. That consistency explains why consumers reach for the familiar box, knowing exactly what experience awaits inside every sealed pouch. The engineers who designed these systems understood that breakfast success requires invisible perfection, quality so reliable it becomes assumed. The workers who operate them take pride in maintaining standards that have made Pop-Tarts the benchmark for toaster pastries worldwide. From ingredient storage to shipping dock, the journey takes just under 3 hours, transforming raw materials into products ready for toasters nationwide. That speed comes from decades of refinement, each year finding ways to move faster while maintaining the quality that built the brand. New production lines currently under construction will increase capacity by 25%, meeting demand that continues growing in emerging markets. But even with expansion, the core recipe remains unchanged. The same dough formula, filling ratios, and frosting specifications that created an icon. Store brands have tried for decades to replicate the combination. None have matched the texture, flavor, and consistency that makes Pop-Tarts unique. The secret is not any single element, but the integration of thousands of details, each one controlled and verified across every batch. 20 million pastries per day, 7 billion per year. Each one carrying the standard that defined American convenience breakfast for 6 decades. The next time you drop a Pop-Tart in your toaster and hear that familiar ding, you are experiencing industrial precision disguised as a simple breakfast. From wheat fields to frosting curtains to the kitchen in front of you, every step calculated to deliver exactly what you expect. 60 years of production, 14 countries. One unwavering standard that transformed a simple idea into a breakfast institution. That is how Pop-Tarts are made. Precision, consistency, and 20 million perfect pastries every single day.